Good afternoon, guys. This is my presentation for biofuels, and today I'm going to discuss both types of biofuels and mention how they are converted from their natural state and why they are better for the environment, and looking into some potential uses for the future. So let's get started. So, what are biofuels? Biofuels are fuels produced directly or indirectly from organic material, which is also known as biomass. This also includes some plant materials and animal byproducts and waste. They can also be solid, gaseous, or liquid. However, when they are transported through trucks, they will be in a liquid form. Biofuels may be derived from agricultural crops, which includes conventional food, plants, or from special energy crops. They may also be derived from forestry, agricultural, or fishery products, or municipal waste. Some of these include fuel wood, wood chips and pellets, organic materials that are used in an unprocessed form, which are primarily used for heating, cooking, or electricity production. Secondary biofuels are what we're going to talk about today, which are a result of processing biomass and liquid biofuels like ethanol and biodiesel. In order to understand biofuels, we have to look at the history behind them. So today I'm going to start with the early uses of biofuels, and we're going to work our way through a couple topics leading into some more sustainable clean energy practices that are being exercised by the United States. So let's start with the Model T Ford. Biofuels have been around since cars have been around. At the start of the 20th century, Henry Ford, who was in charge of Ford Motors, actually planned to fuel his Model T Fords with ethanol. And some early diesel engines were actually shown to run on peanut oil, so this did not seem impossible for him. At the time, the discoveries of massive petroleum deposits scattered throughout the United States and its coastlines kept gasoline and diesel cheap for decades. However, with recent rises in oil prices, along with the growing concern of climate change, carbon dioxide emissions have been a major factor. A lot of the gasoline in the United States is blended with a biofuel, ethanol. Cars are a major source of atmospheric carbon dioxide, which is the main greenhouse gas that causes climate change. Using biofuels as jet fuel also offers a potential solution to carbon emissions from air travel. In 2016, United Airlines announced a new initiative to integrate biofuel into its energy supply, seeking to reduce their greenhouse gas emissions by up to 60%. However, there is limited information on the current status of this initiative. All of these events in recent history has led humans to discover new ways of creating cleaner energy that is also sustainable. And this all started with ethanol. So now let's talk a little bit about ethanol. Ethanol is a type of alcohol that is used in today's beer and wine, if you didn't know that already. It's not designed for human consumption through this conversion process, hence why it is also mixed in beers and wines that are available today. So it is most commonly made by fermenting any biomass high in carbohydrates through a process similar to beer brewing. More recently, ethanol is produced from sugars and starches and undergoing fermentation. In this next slide, I'm going to talk a little bit about how that actually works. Alcoholic fermentation starts with a molecule of glucose or sugar, which is C6H12O6. This will be split into ATP, or energy, which humans break down when contracting their muscles. This will also create pyruvate and a substance known as NAD+. The pyruvate will generate some carbon dioxide and then convert to acetaldehyde, which will then produce ethanol, which is a toxic substance. The takeaway from this is that in order to produce more ethanol, we will need more adenine triphosphate, or ATP, in order to further break down glucose molecules. The glucose also loses an electron to form NAD+, so that when there is more ATP, the process of fermentation may continue. So now let's talk about how ethanol in its natural state can be used and converted into a secondary biofuel. Ethanol is used as a blending agent with gasoline to increase octane and cut down carbon monoxide, among other emissions. The most commonly used blend of ethanol is E10, which is 10% ethanol and 90% gasoline. So basically, the easiest way to figure this out is whatever number is in front of E, which stands for ethanol, would be 10, in which case it's 10%. So if it was E90, it would be 9% ethanol, 10% gasoline. So flexible fuel vehicles are designed to run E85, which is very high concentration of ethanol, which can be anywhere from 51 to 83% ethanol. So roughly 97% of gasoline in the United States contains some ethanol. The most common method for converting biomass into ethanol is through fermentation. This is where microorganisms such as bacteria and yeast metabolize plant sugars and produce ethanol, as mentioned in the other slides. So now let's talk about how biodiesel is actually made through conversion of these vegetable oils and animal fats. So the first step in this process is transporting the tallow, which is a rendered form of beef or mutton fat. These are primarily made up of triglycerides. So these will be transported into a vat where it will initiate the transesterification process, which catalyzes the fat by adding an acidic or a base catalyst, which will produce crude biodiesel. Then it will be brought through a purification process where scientists and workers will incrementally test the biodiesel. It will then be transported to a quality assurance tank for further testing by workers and scientists. It will then be moved to a biodiesel tank where equipment will automatically dispense the exact amount of biodiesel and mineral diesel so that they can be blended. After verifying the ratio of biodiesel and mineral diesel is exact, it will then be distributed to customers and other service stations. Now let's talk about biodiesel. So biodiesel is another liquid fuel that is produced from renewable sources, which comes from new and used vegetable oils as well as certain types of animal fats. It is also a much better substitute for petroleum-based diesel fuel and burns much cleaner, which emits less pollutants into the atmosphere. So this produced substance is non-toxic and biodegradable, which means it can be naturally absorbed by the environment and is able to replace the fuel for these compression ignition engines. However, it is most commonly mixed with petroleum diesel in many fashions. This includes B100, which is pure biodiesel, and B20, which is the most common blend you'll find in the United States, which contains 20% biodiesel and 80% petroleum diesel. So these mixtures are produced by combining alcohol with animal fat, vegetable oil, or cooking grease that has been recycled in your everyday use. So now let's talk about some different type of biofuels, which include cellulosic ethanol and hydrocarbon fuels. So there are some biofuels that are new and advanced, which include cellulosic ethanol and some renewable hydrocarbon fuels. The structure of the plant cell wall must be broken down. The biological molecules in the cell, such as hemicellulose, bind tightly together, which can be achieved through high or low temperature deconstruction. So, high temperature deconstruction uses extreme measures of heat and pressure in order to break down solid biomass into a liquid or gaseous state. So, of these, there are three options that you can choose from. There is pyrolysis, gasification, and hydrothermal liquefaction. Now, when we're talking about low temperature deconstruction, this will incorporate enzymes or chemicals that break down this biomass into intermediates. So this process was allowed to happen because of a pre-treatment process that opens up the plant structure, which allows sugar polymers to be broken down by the enzymes that are introduced in the process into very simple blocks of sugar through hydrolysis. So in conclusion, here's all my sources. If you guys want to learn a little bit more about biofuels, you can click on any of these links, or you can just type in biofuels onto Google. You'll find something good. Thank you guys.